The objective of this topic is to produce quality braze welded lap joint welds in the horizontal or 2F position and square groove braze welds in butt joints in the flat or 1G position on 11 gauge mild steel plate. Braze welding is defined as a jointing process in which the brazing filler metal is deposited into the joint without capillary action or melting of the base metal.
On a drawing, the welding symbol looks like this. On both sides of the lap joint, deposit a fillet weld with 1/4 inch by 1/8 inch legs and a concave face using the oxyacetylene process. Also, on the arrow side of the joint, deposit a square groove weld in a butt joint with a 1/8 inch root opening, complete penetration into the root side of the joint, and with a convex face using the oxyacetylene process.
You'll need some 11 gauge mild steel and some 3/32 inch type R CUZN-C copper zinc filler rods. You'll also need some FB4-A brazing flux. 3/32 inch pre-fluxed filler rods may be substituted for the R CUZN-C filler metal and flux if available. You'll need oxygen and acetylene gas supplies and equipment. You will also need protective clothing, gloves, goggles, a striker for lighting the torch, and a pair of pliers. The torch tip orifice should be a drill size number 56, and you will need the proper size tip cleaner. The oxygen working pressure should be adjusted to 6 pounds per square inch, and the acetylene pressure should also be set to 6 pounds per square inch. The flame should be adjusted to a setting that is slightly oxidizing.
This horizontal lap joint consists of 2 fillet welds. Fillet welds are deposited on both sides of the joint. The butt joint consists of a square groove weld made up of 1 layer, a root pass, deposited using the braze welding technique. The workpiece for this exercise consists of 3 pieces of 11 gauge mild steel plate. The plates are tack welded to form a square groove butt joint and placed in the flat or 1G position. A lap joint is formed when another plate is tack welded to the workpiece and placed in the horizontal position or 2F position.
To make the workpiece, take 3 pieces of 11 gauge mild steel plate, clean and deburr them as needed. For braze welding, flux is needed for preventing oxidation and for absorbing impurities. Light the torch and adjust the flame to a slightly oxidizing setting with an inner cone about 1/4 inch long. A thin, even flux coating is applied to the filler rod by heating 2 to 3 inches of the rod, then dipping it in the powdered flux. The coating should be about a 1/16 of an inch thick. However, it is not necessary to dip the rod in powdered flux if you are using a pre-fluxed filler rod.
Place 2 plates together to form a butt joint and use a 1/8 inch spacer between the plates to make a 1/8 inch root opening. Deposit a 1/4 inch tack weld using filler metal at one end of the plates. Adjust the opening as needed, then deposit a second 1/4 inch tack weld on the other end of the plates. After tacking the butt joint, turn the workpiece over and position another plate on the workpiece to form the lap joint. It should overlap approximately 1/2 of one plate. Use an extra plate underneath for support. With the flux-coated rod, deposit a 3/8 to 1/2 inch long tack weld at one end of the plates. It may be helpful to use a slight torch motion to improve control of the puddle. Rotate the plates, then deposit a second tack weld that is approximately 3/8 to 1/2 inch long on the opposite end.
Place the workpiece on the fire bricks in the flat or 1G position with the square groove joint centered over the space between the bricks with the lap joint facing up. Position the torch on the tack weld with a work angle that is approximately 90 degrees and a 25 to 30 degree push travel angle.
If you are not using a pre-fluxed rod, dip the heated filler rod in flux. Then position the rod over the axis of the joint at approximately a 45-degree angle. Hold the torch in position, and when the metal becomes dull red in color and the flux is liquid, dip the rod into the edge of the joint and deposit some filler metal. Do not melt the base metal. The filler should flow into the joint opening and spread out slightly where there is flux. This spreading of the filler metal is referred to as wetting or wetting out. If you need to stop welding, withdraw the filler metal and then gradually move the flame away from the puddle.
Traveling too slowly or not using enough of a push travel angle increases the heat on the puddle, which may result in too wide a braze weld or melting of the base metal. Using too much of a push travel angle or using too fast a travel speed reduces the heat on the puddle. This results in a narrow weld bead with a weak bond and incomplete penetration. Before restarting a braze weld, if you are using non-fluxed filler rods, always add flux to the brazing rod before you begin welding. To restart, position the flame at the back of the weld crater and gradually heat the weld to create a puddle. Once the puddle is formed, move forward, then begin to add filler metal and continue welding. Travel smoothly down the center of the joint. Direct the flame so that both plates are bonded by the filler metal to produce a weld face that is approximately 3/8 to 1/2 of an inch wide. Upon reaching the tack weld at the end of the joint, melt into the tack by about 1/16 inch, and then add filler as needed to fill the puddle to the proper bead height. Gradually reduce the heat on the puddle, then remove the flame.
If you travel too slowly into the tack weld, you could melt through the tack. The root side of the finished braze weld should be flush with the surface of the base metal to a maximum of 1/16 inch root reinforcement and complete bonding with both sides of the joint. The face side of the braze weld should be flush and approximately 1/2 inch in width, with a complete bond into the edges of the joint.
Allow the workpiece to cool briefly or switch to another workpiece. Then prepare to deposit the fillet weld on the lap joint. Position the torch with a work angle that is approximately 45 degrees. Use a 25 to 30 degree push travel angle. The filler rod will be held over the axis of the joint at approximately a 45 degree angle.
Hold the torch in position, and when the metal becomes dull red in color, touch the rod to that spot on the metal to melt a little flux and filler. Once again, be careful that you do not melt the base metal. Just heat the metal until it is hot enough to melt some of the flux when touched to the base metal. When the flux is liquid, dip the rod at the edge of the upper plate to deposit some filler metal. The filler should flow into the joint opening and wet out slightly. Continue dipping the rod and moving forward along the joint. Travel along the joint from right to left with a smooth and steady travel, adding filler metal as needed to fill the joint and produce the appropriate size fillet weld.
Dip the rod in flux to replenish the supply when needed. However, if you are using pre-fluxed filler rods, continue welding and direct the flame so that the joint is filled completely with the filler metal to produce a braze weld that is approximately 3/8 to 1/2 inch in width. When the braze weld is complete, clean the excess flux from the workpiece with a wire brush.
If you add the filler metal onto the lower plate or direct too much heat there, the lower leg of the weld will be too long. Too fast a travel speed or not enough heat will produce a narrow, convex bead that does not bond with the workpiece at the edges of the bead. Too much heat will produce a rough, discolored weld. A white powder of oxidized zinc might be present, and the braze weld may be excessively concave on the face. Too much heat may also cause the braze weld to crack.
Once you have completed the weld, allow the workpiece to cool briefly or switch to another workpiece. Flip the workpiece over and reposition it so you can weld the lap joint on the opposite side. Deposit the fillet weld using the same techniques as before. Be sure to maintain consistent work and travel angles as you move along the joint.
The finished weld should be flat to slightly concave, bonding thoroughly with the surfaces and edges of the joint. Inspect your welds and continue practice.